Take out my highlighter on this one. This time, the key word here is evaluate. Evaluate means we want to get a number as an answer. Is this calculator or non-calculator? We're going to do these without a calculator. So initially we look at A here and we're like, oh, Mr. JR, no, I'm not doing this without a calculator. Because when I see log 9 of 6, I think, what does log mean? Log solve for exponents. It's like putting a little question mark there. 9 to what exponent is 6? That is not in my brain whatsoever. So I feel like this is not easy to do. How is this a non-calculator question? Well, it also has minus log 9 of 72. And if I think of that on its own, can I do that in my head? 9 to what exponent is 72? You know 9 squared is 81. It's like 1.9, 1.8. But do I know all the decimals? And I'm supposed to evaluate this expression. So in the current form, it's not possible. However, maybe I can combine this as a single logarithm and it simplifies to become something easier. So this 3, what could I do? I could put that in, I'll stick with black. I put that 3 in as an exponent, 6 cubed minus log 9 of 72. And then subtracting, I have a log law that says when I subtract, that's like dividing inside my exponent. Now you might have noticed I had that 6 cubed. Some of you might have been tempted to be like, really show off your prowess with your powers chart. 6 cubed is 216 and be like, oh, I want to write 216 right away. That's perfectly fine if you did that. And then you'd have 216 divided by 72, which might take your head a little bit of time to do that as well. But I want to show you some shortcuts when simplifying, when dividing. I'm actually not going to multiply that 6 cubed out to be 216. Instead, I'm going to take things here and break them up instead. Do you see that 72 is 2 times 36? And 36 is 6 times 6. If I get a little devilish here on the top, I could write 6 cubed as 6 times 6 times 6, and things will simplify really nicely. In fact, by breaking it up, I don't even need to know that 6 cubed is 216. I don't have to struggle with 216 divided by 72 and get 3. I have to struggle with 6 divided by 2. Whew. All right. Anybody double check that for me on a calculator? Am I good? All right. But now we still have a little bit of a challenge. We've simplified this. It still said evaluate, log solve for exponents, and so we're still trying to solve for this, and this is a little tricky. 9 to what exponent is 3? And for a lot of us, for some of us, if you're good, you'll be like, oh, I know this. And if you're good and you know this, and you write a half, perfect. Did you know 9 to the half is equal to 3? Some of us are shaking our head because we don't see that right away. Remember, an exponent of a half is the same as a square root. Is the square root of 9 3? Yes. But would my brain see that half? If it doesn't, we go to our technique that we were doing the other day. I want to solve this. I am going to introduce the variable x and let x equal log 9 of 3. And since I'm much more comfortable with exponent form than log form, I change this to exponent form. This is my log form. In exponent form, my base is 9, log solve for exponent, so my exponent is x. This is equal to 3. And we learned that if you have a non-calculator question solving these, they need to be in the same column on the powers chart that we made. And you see that 9 is 3 squared. So we could change 9 to 3 squared, still have the x there. And exponent log to exponent is multiplied. This side is technically 3 to the 1. And then I go, so if I had the bases the same, these exponents would have to be the same. 2x would have to equal 1, and solving for x, I would get the half. That's a lot of extra. There's a little bit extra. Well, I can't even put it on the same page right there. I could have originally just known that. But some of us said, I didn't know that. I didn't see the half as the answer. And especially if it was an answer like a cube root, or a fourth root, or a 3/4 root. That's hard. I think that's the first time in my life I've ever said 3/4 with a th on the end. A 3/4 root. Right? If I don't see that, the blue is the technique that I could do using what I learned from before to get that half the same way. Nice to know that I can do that. Okay. I am going to erase this. Has everybody got this down? Everybody's good? Okay. I'm going to erase this so we can see question B. While we're doing it, again, it says evaluate. I look at these and I do not know 4 to what exponent is 6, 4 to what exponent is 3, 4 to what exponent is 12. So combining them as a single log might be helpful. So I'm going to put in my exponents for first. 6 squared minus log 3 of 3 cubed plus, oops, not log 3. Still a base of 4, log 4 of 12. Since my bases are the same, I can use my log laws. So that's having these all be 4s. When I wrote the 1 as a 3, I was like, uh-oh, something's not looking right. I can only use those log laws for adding and subtracting if the bases are the same. Since the bases are the same, I would use the shortcut here. Which ones are added? The 6 squared and the 12. Which ones subtracted? The 3 cubed. Again, I could multiply the 6 squared out and get 36. Right? I could multiply 36 times 12. Do you know your 12 times table up to 36? That's up there, isn't it? Yeah, it's not like 436 or something close to that in my head, but I'm not confident. So no, but we can simplify this by breaking the factors up. Right, what am I going to have on the bottom? We have 3's. So in order for those 3's to cancel out, I'm going to need 3's on the top. I have 6 times 6, which is 3 times 2. I put them in brackets like that so you could still see the 6 times 6. And I'm going to put the 12 as 3 times 4. I'm going to keep that in brackets too. So you can really see this was 6 times 6 times 12. I broke that up now. All of those 3's will go away. And what am I left with? 2, a 2, and a 4. 2 times 2 times 4, that is 16. Do we need to use the other technique, or is this one you can just see? 4 to what exponent is 16? 2. 2. Okay. Perfect. So this one was, the final answer was a little bit easier to work with. But that combining as a single logarithm, now we see the simplifying actually help us evaluate a question that the individual parts were not easy to do. Okay, circle question number 13.